Hi all, thank you very much for having us in this beautiful and quite inspiring, I would say, event. My name is Stavros Keppas and I am the lead meteorologist of WeatherExam. Okay, this is a bit of a spoiler, but yeah, so I work in WeatherExam, which is a company that tries to develop a global weather station network and tries to improve the weather forecast accuracy. So yeah, I'm starting my presentation with this simple or not question, which is, what if we had fewer weather observations? What would happen if we had fewer weather observations on Earth's surface and in the atmosphere? And I'm going to answer this question using a real-life and up-to-date example. So in early 2020, due to the pandemic, there were lots of restrictions. We experienced lots of restrictions, and one of these was the reduction in the number of daily flights by 50 to 75% on a global scale. And so you can see this sudden drop actually in the number of the flights in March and April 2020. This is actually another graph that shows the number of flights on the same day in 2019, in April, and 2020. We can see this huge reduction of the number of the flights. And why am I saying this? How this is related to weather? It is related because the aircrafts are equipped with meteorological sensors. So they measure the weather conditions in the upper troposphere. And so the reduction of these aircraft flights actually caused the lack of observations, of weather observations. And these weather observations are used, or at least this is one of the parts of observations that are used by weather models in order to produce forecasts. So this lack of observations reduced the 6-hour forecasting ability by up to 15%. And of course, this fact triggered further research, and it was found that if we removed aircraft observations by 100%, so we didn't have any observations by aircrafts, this would decrease the forecast accuracy by up to 50%, especially during the winter. So, okay, we talked about weather observations and how they are used in the forecast process, but this is only one of the aspects. We use weather observations in order to build also a climatic time series of data. So what is the difference, though, between weather and climate? This is another question. So let's clarify this. With the word weather, we describe the current situation of the atmosphere. We describe the weather conditions that we have right now or in a short period of time. So we can say, for example, that the weather outside now is partly cloudy, the temperature is around 24 degrees Celsius, and the relative humidity is about 50%. Or we can say also that the weather during the last hours, the days, or even weeks was mostly rainy, and the temperature was around the climatic levels. But, okay, here's another question. How can we define climatic levels? So we need to know the climate of a region. And in order to know the climate of a region, we need to have a large archive of data. So we need weather observations for a long period of time in order to be able to say that in a certain period of time, at a certain place, the average weather is around that, is hot and dry, for example. If we go to Spain in August, we should experience hot and dry weather, because this is the climate, because this is the average weather there. And of course, scientists, if they want to make some analysis of the climate of a region, they need 20 or even 30 years of weather observations in order to get some conclusions about the climate of the area. So we use, how do we measure this? Weather observation, how do we measure weather and climate? We use weather stations. And it is quite, I mean, these observations are really valuable, because in order to build a time series of climate data, we really understand how valuable are these observations, because it takes a lot of time to get all these time series with no gaps. And this is a WeatherExam weather station. It is an automatic station, and the advantage here is that, firstly, there is no need for, we need limited supervision. So there's no need someone to go there and manually record the weather observations every hour or every minute. And the second thing is, the second advantage is that we don't need a large area of deployment. So it's just a metallic mast, and we place on the top this set of sensors. Okay, we spent time, we spent money. I don't know what other we did. So we got all this data. We were waiting for long years in order to get the climatic data, but who actually cares about weather and climate observations? Okay, I'm a weather geek, so I really need to know what is the weather outside my house, just because I want to know that if there is a thunderstorm around, I want to go there and chase it. But this is just a small proportion of people. So yeah, there are people like me that are interested in this, in weather, but there are people like you that want to invest, and this investment is affected by weather and climate. So these are some of the industries and sections of economy that are interested and are affected by weather and climate. So agriculture, energy, transportation, which includes aviation and shipping, sport activities, insurance, which is an industry that is affected, is really interested in the risk of the extreme weather in the future. For example, tourism, which is a quite important sector of economy for some countries, and property management. So there are people that they need to know remotely if their property is in danger because of extreme weather events. And of course, the list goes on and on and on. And there are even small-scale activities that we do every day in our life, and they are affected by weather. So we need to know what is the weather now and what the weather will be in the future. Okay, the second question that comes to our minds is, why do we care about the weather and the climate? So we need this information in order to plan, protect, and optimize. So we need climate in order to be able to plan our investment. For example, we need to know the climate of an area in order to plant a vineyard, for example. So we need to know if the climate is ideal, for example. Or we need to know if this is the ideal place to construct a solar farm. And then we need weather, the current weather, and the weather in the future to protect, to increase the functionality, and to optimize, finally, eventually, our activities, our ventures. So yes, we need to forecast. We need to know the weather in the future. But in order to do this, we need to know what is the weather right now. Why is that? So these are the words of a meteorologist, Wilhelm Bjerknes, in 1904. But he said that latter atmospheric conditions are linked with previous ones through the physical laws. So we have the past, we have the current situation, or the future, and there are some equations somewhere here that make simulations about all these atmospherical processes, processes that occur in the atmosphere. So in order to forecast, what are the two keys, the two key ingredients for a successful forecast? The first one is the accurate knowledge of the physical laws. So we need to know what are all these processes in terms of math and physics and that occur in the atmosphere. Okay, all these processes are quite imperfect right now. And of course, there's a lot of research on this and will be in the future as well. But the other thing that we don't have is the accurate knowledge of the current state of the atmosphere. So we need to know what is the weather now in order to feed the models which will calculate the different processes and finally will produce weather forecast. And I will try to explain in a simple way, in simple words, what is the process in order to produce forecast, a weather forecast. So the first step is the data simulation. It is really important. This step is really important. So we actually do a combination of observations, weather observations, and the latest produced forecast. So we have a simulation on the one hand, and we have weather observations on the other hand. And we try to combine them in order to understand in order to get the best representation of the current state of the atmosphere. And why do we do this? Because we don't have observations at every point of the planet and the atmosphere. So we try to fill the gaps. And okay, maybe it sounds a bit simplistic, but it's not, believe me. So after we produce the current state of the atmosphere, this good representation, and we have this data set, we feed the models. So a model actually divides the Earth surface in the atmosphere into cells with a certain size. And this size is determined by the spatial resolution of a model. So if we say, for example, that the spatial resolution of a model is 10 kilometers, that means that this cell, every single cell on the surface and in the atmosphere has dimensions, is actually a cube with dimensions of 10 kilometers. So we feed every single cell with the product of data simulation, and then the model simulates all these physical processes in the atmosphere in order, finally, to produce the forecast, to show us how all the meteorological variables change in the future, in time and in space. And this is the forecast, actually. So, okay, we've got a model, we simulate the situation, and we got forecast. But is that enough? So now, do we know the weather in the future? The answer is probably no. So different models use different approaches, but this is not the only case. Here we can see another example. It's actually another process that we follow sometimes. It's the ensemble forecasting. So we have multiple models, sometimes, as in this case, with the same approach, let's say, scientifically. And what we change is the initial conditions, so the current state of the atmosphere. We change the initial conditions that we feed the model, and then we feed the models, and then we want to see how these errors will evolve in the future. So what we can see here is that at the beginning, there is a great agreement between these models. This is temperature, it doesn't matter, but this is temperature in the middle troposphere, and we can see the forecast for 15 days. So we can see at the beginning, there's a good agreement between all the models. But this small error that we introduced at the initial stage, we can see that after the third day, increases. And finally, we can see that this is actually magnified in a chaotic way in the future. So we can see that 10 days after, we could expect from a real winter to something like spring. So here we can also understand the value of weather observations. We need good quality observations. Okay, what about WeatherExam? What is the role of WeatherExam in all these things? So we try to develop a global weather station network in order to get all this data, to get well-distributed data across the globe, and to get good quality data. And in order to do this, we use the Web3 technology in order to give an attractive incentive to people to deploy and also to maintain their weather station. This is really important. We not only need to deploy a weather station, we need to maintain this weather station appropriately. So we design the hardware, the software, and the infrastructure around Web3 technology, and we will use our token, our company's token, in order to reward station owners for the good quality data that they will share with us. And so we develop all these mechanisms to ensure the quality of data provided by the users. And so in order to do this, we cleanse, we supervise, and we reward not only the collection, but also the distribution of the weather data, in the spatial distribution of the weather data, in order to make, finally, better weather-related decisions. And of course, to provide a better forecast for each region in the world. So, closing this presentation, I would like to say that WeatherExam is here to help the planet make a better weather-related decision, better weather-related decisions, because we actually work on one of the key ingredients for a successful forecast, which is the weather that we measure, collect, and share. And we do this in a fair way using the Web3 technology. Thank you very much for your attention. Please join us. We are, this project is quite new, and so we are open to discussions. We need to find solutions to our problems, and we are open to discuss this with you. There are also brains here that can help us in this. And of course, we also need to identify also new problems that may arise in order to find solutions in these problems. Thank you very much once again.